00115, 115 345, 345 515, 515 645, 645 815, 815 10. Visual cue, close-up of a weathered Wandu log. The camera glides inside, revealing a sleeping numbat curled into a ball, its bushy tail tucked tightly around its face. Audio cue, the rustle of dry leaves accompanied with soft atmospheric kello. Narrator, VO. While the numbat's anatomical adaptations for hunting termites are extraordinary, its survival hinges equally on an invisible asset, the architectural layout of the bush. For a numbat, a hollow log is not merely a place to rest. It is a critical thermal refuge and a fortress. Because numbats have a relatively low metabolic rate and a diet low in energy value, they must strictly conserve every calorie. During freezing winter nights, temperatures in the Australian woodland can plunge towards zero. Without the insulating microclimate of a hollow log filled with leaf litter and shredded bark, a numbat simply could not maintain its body temperature. Visual cue, an eagle circles high above. On the ground, a numbat freezes mid-stride, flattening its body against a fallen branch, blending into the bark. Narrator, VO. This reliance on fallen timber also shapes their unique anti-predator ethology. For millions of years, the numbat's chief adversaries were aerial hunters, like raptors. In response, numbats evolved a freeze and camouflage strategy. When a bird's shadow passes overhead, a numbat will instantly immobilize, relying on its disruptive striped markings to break up its silhouette against the forest floor. If spotted, it bolts at remarkable speed directly toward the nearest hollow log, wedging itself deep inside. Once inside, it uses its thick skin and tough rump to block the entrance, making it incredibly difficult for a bird of prey to extract. However, this ancient defense mechanism is precisely why introduced predators have been so devastating. Feral cats and foxes hunt by scent and sound, tracking the numbat directly to its refuge, where a hollow log can unfortunately become a trap. Visual cue. Inside a conservation lab, a scientist extracts DNA from a hair sample, analyzing genetic markers on a screen. Narrator, VO. This intense predation historically reduced wild numbats to just 2 isolated strongholds in Western Australia, Dryandra and Perup. This introduced another silent threat: the genetic bottleneck. When a population plummets, genetic diversity drops, leaving the species vulnerable to disease and inbreeding. To combat this, modern ethologists and geneticists cooperate in a highly precise genetic matchmaking program. Animals from different wild regions are carefully paired in conservation facilities to maximize genetic health, ensuring that the generations released back into the wild possess the robust immune systems required to survive. Visual QE. A field researcher gently fastens a miniature radio collar around the neck of a healthy adult numbat before releasing it into a sanctuary. Narrator, VO. The process of returning these captive bred numbats to the wild is a science in itself, known as rewilding. Scientists utilize soft-release techniques where numbats are placed into large, predator-proof acclimatization pens within their new habitat. This allows them to adjust to the local climate, locate wild termite galleries, and establish home ranges before the fences are opened. Each released individual is monitored using these tiny radio transmitters. This allows field biologists to track their movements across thousands of hectares, monitoring their survival, nesting habits, and reproductive success, providing real-time data to optimize future conservation efforts. Visual QE. The camera pans across a protected landscape at sunset. A numbat successfully wild forages, its tail twitching with vitality. Narrator, VO. What the numbat teaches us is that wildlife conservation cannot happen in isolation. To save this species, we must save the old-growth woodlands, protect the fallen timber, and rigorously exclude introduced predators. By securing the future of this ancient termite-eating machine, we preserve the vibrant, living history of the Australian continent, ensuring its quietest wonders continue to walk the earth. Visual cue. a controlled, low-intensity cool burn trickling through the undergrowth of a dry Wandu forest. Native grasses smoke gently, but the large, heavy fallen logs remain untouched by the creeping flames. Audio cue, the gentle, rhythmic crackle of embers, transitioning into a steady, hopeful acoustic melody with driving strings. Narrator, VO. Beyond managing introduced predators, securing the long-term future of the Numbat requires mastering one of the most volatile and misunderstood forces on the Australian continent: fire. In these dry sclerophyll woodlands, fire is an ancient, natural, and necessary part of the ecosystem. However, the specific type of fire makes all the difference between habitat rejuvenation and absolute ecological catastrophe for this highly specialised marsupial, high-intensity wildfires, which have become increasingly frequent and severe due to shifting global climates, are utterly devastating to local wildlife populations. These intense megafires do not merely clear away the undergrowth. They incinerate the large, decaying fallen logs that numbats completely depend on for sleeping, breeding, and escaping predators. When a forest loses its dead timber, it can take more than half a century for new hollow logs to form naturally, effectively rendering the habitat unlivable for generations of numbats. Furthermore, a blackened, barren landscape leaves surviving numbats entirely exposed to any aerial predators hunting from above. Narrator, VO. To solve this complex environmental challenge, land managers and ecologists are increasingly looking to ancient land management techniques, integrating traditional indigenous cultural burning practices with modern conservation science. By introducing low-intensity, cool burning fires during the damp winter or early spring months, land managers can effectively reduce the fuel load, the dangerous accumulation of dry leaves and twigs, without destroying the vital hollow logs. This careful, deliberate approach creates a diverse mosaic landscape. This patchwork of burnt and unburnt areas provides a dual benefit. It stimulates fresh plant growth that rejuvenates local termite colonies, while simultaneously leaving ample, unburnt cover for numbats to forage safely without losing their essential networks of refuge. Visual cue, close-up of a local volunteer carefully setting up a motion-activated camera trap on a tree trunk. Cut to night vision or infrared footage captured by the device, showing a healthy numbat scurrying past, its bold stripes perfectly clear. Narrator, VO. While state environmental agencies and large-scale conservation groups spearhead these massive landscape management projects, some of the most inspiring breakthroughs in numbat protection are happening right at the grassroots level. This is where citizen science plays a truly monumental role. In Western Australia, where the numbat holds the proud title of the state's official mammal emblem, community groups like the Numbat Task Force have proven that ordinary citizens can make an extraordinary difference to scientific research by deploying and monitoring hundreds of remote camera traps across known habitats. Everyday volunteers provide researchers with thousands of hours of invaluable field data. This massive collective effort allows scientists to map out exactly where individual numbats are moving, track overall population density, and identify specific zones where feral predators might be attempting to breach security perimeters. It is a powerful reminder that modern wildlife conservation does not just happen in a remote laboratory. It thrives when an active, educated community is directly invested in a species' survival. Visual cue. A beautiful, wide-angle tracking shot following a numbat as it confidently climbs over a mossy log, its bold stripes catching the warm afternoon sun. The camera tilts up to reveal the vast, open canopy of a healthy, thriving Australian woodland. Narrator, VO. The story of the numbat is a compelling microcosm of the wider global conservation challenge. It highlights just how quickly a species can slide toward the brink of extinction when human actions disrupt a delicate ecological balance. But it also proves that with targeted, scientifically backed intervention and unwavering dedication, we can successfully reverse the damage The numbat is a remarkable survivor against incredible evolutionary odds. Having outlived all its closest prehistoric relatives, it continues to hold its ground in the quiet, sun-dappled corners of the Australian bush. By valuing these unique creatures, by protecting their forest homes, and by understanding their complex, essential place in the ecosystem, we ensure that Australia's unique natural heritage remains intact for generations to come. The ongoing fight to save the numbat is a profound testament to what we can achieve when we choose to actively protect, cherish, and understand the wild world around us. Visual cue. The screen slowly transitions to a clean, minimalist graphic featuring educational resources and official conservation links. The music reaches a resonant, inspiring crescendo before fading out completely. Visual QE. A high-quality 3D digital animation comparing the skull and jaw mechanics of a South American giant anteater alongside the delicate, slender skull of an Australian numbat. Graphic highlights illuminate the structural differences in their jaw articulation and limb density. Audio QE. A precise analytical electronic pulse blending into a steady, rhythmic bassline, establishing a tone of scientific inquiry and clarity. Narrator, VO. To truly appreciate the evolutionary marvel of the numbat, it is highly valuable to look at it through the lens of convergent evolution. This is the fascinating biological process where completely unrelated species develop remarkably similar physical traits because they are adapting to identical ecological niches. Across the globe, mammals that specialize in eating social insects, like the giant anteater of South America or the pangolin of Africa, share an unmistakable external blueprint: elongated snouts, long sticky tongues, and reduced dentition. However, looking beneath the surface reveals a stark structural contrast that dispels a major misconception. The numbat is often colloquially referred to as the striped anteater, but this title is both taxonomically and functionally incorrect. Placental anteaters are heavily built, tank-like mammals with completely fused, toothless jaws and massive, bone-crushing claws designed to rip open concrete-hard mounds. The numbat, by contrast, is a lightweight, agile precision instrument. Its jaws are not fused, it retains up to 52 small peg-like evolutionary teeth, and its claws are sharp but delicate. It simply does not possess the physical power to destroy an established termite mound. Instead, its entire hunting strategy relies on speed, stealth, and a highly acute sense of smell to intercept the insects in their vulnerable, subsurface transit tunnels before they have time to retreat. Visual cue. Macrophotography of a column of black ants marching next to a column of termites. A numbat enters the frame, completely bypassing ants to feed exclusively on the termites. Narrator, VO. This brings us to a critical ethological distinction that corrects another widespread myth. Numbats do not actually like eating ants. While the words ant and termite are frequently used interchangeably in casual conversation, these insects belong to entirely different taxonomic orders and present completely distinct chemical profiles. True ants belong to the order Hymenoptera, closely related to wasps and bees, and are heavily armed with potent chemical defenses, specifically painful stings and high concentrations of caustic formic acid. Termites, on the other hand, are actually highly evolved, social cockroaches belonging to the order Blattodea. They lack formic acid entirely, making them far more palatable, and their bodies are significantly richer in essential fats and proteins. The numbat's digestive system is uniquely calibrated to process this fat-rich, toxin-free diet. Bypassing ants is a deliberate survival choice. The numbat's delicate palate simply cannot tolerate the chemical warfare of an ant colony. Visual cue. Thermal imaging footage of a numbat curled up inside its log during a chilly winter dawn. The graphic display shows its body temperature dropping significantly before steadily rising as it steps out into the morning sun. Narrator, VOO. Living exclusively on a diet of termites introduces another severe physiological constraint. It is a highly secure food source, but it is incredibly low in individual caloric value. To survive on this low-energy fuel, the numbat employs a fascinating metabolic mechanism known as daily torpor during the freezing winter months, when morning temperatures drop and termites remain inactive deep underground. The numbat does not waste precious energy trying to keep its body at a constant high temperature. Instead, it enters a state of controlled dormancy, intentionally lowering its metabolic rate and allowing its core body temperature to drop from its normal 34 degrees Celsius down to as low as 19 degrees Celsius. This brilliant energy-saving mechanism reduces its fuel consumption during the leanest hours of the day. As the sun climbs higher and warms the landscape, the numbat uses the external heat to warm its body back up, safely awakening to begin its daily forage. By breaking down these complex mechanisms, we move away from the sensationalized myths and begin to see the numbat for what it truly is: a highly sophisticated, perfectly balanced biological masterpiece. Visual cue: a shifting perspective from the deep forest to the rural urban fringe, a modern Australian home bordering a native woodland. A domestic cat sits contentedly on an indoor windowsill, watching the birds outside. Audio QE: the gentle grounding tones of an acoustic guitar, accompanied by a warm, welcoming ambient swell. Narrator VO. While the large-scale efforts of scientists, geneticists, and land managers are absolutely vital, the ultimate survival of the numbat does not rely solely on remote sanctuaries and predator-proof fences. It depends heavily on the choices made by everyday people. Understanding how our daily habits intersect with the fragile ecosystems surrounding our towns and suburbs is the most practical way to ensure these incredible fell animals have a future. The single most impactful action begins right at home with responsible pet ownership. In Australia, domestic cats can take a heavy toll on native wildlife if allowed to roam. For those living near regional bushland or on the urban-rural fringe, keeping domestic cats contained inside the home or within secure outdoor enclosures, often called catios, is a profound act of conservation. It is a simple, highly effective measure that entirely eliminates the risk of predation, protecting not only the diurnal numbat, but dozens of other vulnerable, night-active marsupials and native birds that share its habitat. Visual: a group of bushwalkers on a marked trail in a national park. One hiker stops to admire a large fallen log but leaves it completely undisturbed, stepping carefully around it. Narrator VO for those who love exploring the spectacular Australian bush. Practicing ethical recreation is another critical pillar of support. When camping or hiking through dry woodlands, there is a common temptation to forage for fallen branches and hollow logs to feed an evening campfire. However, as we have discovered, this dead wood is the literal life support system for the numbat, providing its only protection from extreme weather and hunting predators. By choosing to bring sustainably sourced firewood from home instead of clearing the forest floor, and by strictly staying on designated walking tracks, we preserve the vital architecture of the woodland. Leaving fallen timber exactly where it lies ensures that a foraging numbat always has a sanctuary within reach when danger approaches. Visual cue: a vehicle moving at a safe, steady pace down a winding rural road lined with eucalyptus trees. A clear yellow road sign features a silhouette of a numbat with the words "Reduce speed at dawn and dusk." Narrator VO. Being mindful on the roads can quite literally save lives. Because numbats are strictly active during the day, they occasionally cross regional roads and tracks while expanding their home ranges or searching for new termite sources. Adhering to speed limits in wildlife corridors, keeping a watchful eye on the road verges, and avoiding driving through known habitat zones at high speeds during their peak foraging hours can prevent tragic, avoidable collisions. Ultimately, the story of the numbat challenges us to rethink our relationship with the natural world. True wildlife ethics go far beyond passive admiration. They require us to become active participants in the preservation of our shared environments. supporting science-backed conservation organizations, participating in community-led weed and feral pest control programs, and advocating for the protection of remnant, old-growth woodlands are tangible ways to convert awareness into meaningful action. Visual cue: a beautiful, close-up tracking shot of a numbat's face as it pauses in a patch of bright sunlight. Its dark eyes clear and alert. The camera slowly draws back, showing the animal blending seamlessly into the vast, resilient expanse of the timeless Australian landscape. Narrator, VO. The Numbat is a living bridge to Australia's deep evolutionary past. A beautifully unique, irreplaceable masterpiece of natural design that has weathered millions of years of environmental shifts. It does not demand vast territories or complex conditions to thrive. It simply requires the space to exist safely, a supply of fallen timber, and a community willing to protect its boundaries. By ensuring this quiet, striped anteater continues to walk the forest floor, we do not just save a single species from vanishing into the history books. We make a profound statement about the kind of world we wish to build. One where humanity walks hand in hand with the wild, preserving the beautiful. Intricate machinery of nature for all the generations yet to come. Visual QE. The screen slowly transitions to black. A clean, premium text slide appears. Every small action protects our unique wildlife. Learn more at numbat.org.au. The music reaches a warm, emotionally resonant conclusion before fading away entirely.